All right, welcome back. We're in 6.3, which is on matrices and systems of equations. So we'll start with the system of 2 by 2 so that we can see what's happening and see what a matrix is. But to start, a matrix is essentially just a different visual way of dealing with systems of equations. A visual representation and method of dealing with systems of equations. So if I have a system, let's say 2x minus 3y equals 7, and x plus 4y equals -2, right? I can recreate this all in one kind of mathematical object, that is the matrix, by just taking the coefficients, 2, 3, the coefficient in front of this x is a 1, and then a 4, and I'm going to augment it, right? This little line right here is essentially the equals bar, but I'm going to augment that with these two numbers on the right, 7, -2. And so now, this is not a great, let me just steal the picture from the book. I stole the example from the book, so I'm going to steal this picture of what I wanted this to look like, and that is this, right? Square brackets on the sides, right? And then the coefficients on the left. Oh yeah, which is, I wrote mine wrong. That's a -3. But this is the matrix, right? So we have the, on the left hand, this is the coefficient matrix. And then we've just got a straight line. This is the augmentation, or the augment bar if you want. And then over here, the right-hand side of this is the, well, it's what we augment the matrix with, but that's called the constants. Just the numbers that we got from the right-hand side of the equation, right? So what we're going to do with these matrices is go through and solve systems, right? And so we need to know what we can do with a matrix in order to get through and actually solve something. And so we have essentially these operations that we can do, and this is more or less what we did in the last section or two. We just didn't really identify them by calling them things that we can and can't do. But in a matrix, you can do these three things. You can interchange any two rows. Sometimes it's convenient to write one equation before the other. So you're just swapping the order in which the equations are. You can multiply any row by a non-zero constant. That's like multiplying the left hand of the equation by whatever, 5, multiply the right hand by 5 as well. You're just multiplying the entire row of the matrix by whatever, 5 if it is, in that instance. And then we can also do number 3 here, says add a non-zero multiple of one row to another, right? That's basically the elimination method, just kind of done in a snap, right? Multiply a row by a number and add it to another row. That's the idea behind that, is typically to eliminate one of the variables, right? So these are the 3 things that we can do. Let's take a look at actually doing some of those things, right? So the first method that we want to do is called Gaussian elimination, and we kind of glazed over this when we talked about it first. I'm going to I'll introduce it here because I'm sure you'll have questions in your homework about it. But the idea is that you want your matrix to end up looking like this. And this should look familiar. We had the Gaussian elimination where we wanted to get, HZ equals K or whatever it was. But in a matrix, we just want to get it all the way down to ones down this diagonal, right down here, and then zeros below it or to the left of it, right? Because this is my X column, this is my Y column, and this is my Z column. So this matrix, if I just look at this very last row, there's no X, no Y, but this is the equation Z equals, and then whatever that F value is. So in other words, I've solved for Z. And then I can back substitute that up into here, D times Z, right? Plus your Y equals Z. And then you back substitute like we did in our previous sections, right? So let's see this in work. It's weird to talk about it with just general A, B, C, D here. So let's do one. And I'm going to steal this one from the book because that's what I do. Here is a system. Right. So we're asked to solve this. Solve, and specifically solve by Gaussian elimination. So the first thing that I want to do is write this as a matrix. So I'm just going to grab the coefficients, right? My top row is 2, -1, 4, and -3. And then 1, -2, -10, and -6. And then 3. There's no y's here, right? So it's a 0, and then 4, and 7, right? Now, again, the point was to get, I can't steal that, so we'll just scooch up. The point was to get these guys here, those guys, to be 0, right? I want those to end up being 0, and then I'll want to try to get this, ones down the column. So the method that I'm going to use is to try to get a 1 in that spot, right? If I look back up at the possible ways that I can manipulate this, I can interchange 2 rows, I can add a multiple of another row to that row, or I can multiply a constant through that entire row. But you can see the easiest way to get a 1 there is to swap rows. If I take these 2 rows and just switch their places, that gets me the 1, right? So that's what I'm going to do is I'm just going to swap those 2 rows. So I'm going to write it this way. I'm going to write swap row 1 as a lowercase and row 2 as a lowercase, because I'm going to use R is like R1 is my old row 1. And if I ever need to reference a new row 1, I'll call it capital 1. Just kind of a matter of keeping things tidy. But if I swap these 2 rows, then row 2, which is 1, -2, -10, and -6 is first. Row 1 is now row 2, so that's 2, -1, 4, -3. And I didn't touch row 3, that's 3, 0, 4, 7. Right. Now, the reason that I got that 1 right here is because I'm going to scoot back and show you these guys again. I'm going to use number 3. that says I can add a non-zero multiple of one row to another row. So that means I can use this one that I have to eliminate the 2 and the 3 to get me the zeros that I need, right? So on the right-hand side, I'm going to write what I'm doing, but I'm going to take -2 multiplied by old row 1 and add it to old row 2, and that's going to become my new row 2. Now, the reason that I'm doing that is because if I take -2 times row 1, -2 times this entry is -2, and if I add it to that entry, I get a 0, right? So sometimes it's nice to see the work before you write it. So if I do -2 row 1s, that is -2, +4, +20, and +12. It's just multiplying 2 through that entire row. Times -2 gives me that new row, right? And if I'm adding row 2, I can just leave row 2 as it is. That's just 2, -1, 4, and -3. If I add those together, I get a 0, a 3, a 24, and a 9. And that's going to be my new row 2, right? So when I come and write this next version of my matrix, my new row 2 is 0, 3, 24, 9. I'm not going to change 1, so I'm going to write 1 as well. That's 1, -2, -10, and -6. But I'm changing 3 in the same manner. And I'm going to take -3 times row 1 and add it to row 3, because specifically, -3 times this first element will give me -3. Adding it to 3 is going to give me 0 in this spot. That's what I want. But again, visually, I'm going to multiply -3 times my old row 1. That's going to become -3, +6, 30, and then +18. I can't see what I'm writing anymore. Let me scoot this over. There we go. And then if I, in just adding row 3, I'm just going to write row 3 under it. That was 3, 0, 4, 7. And if I add these two together, the 3 and the -3 and the 3 is 0, right? So essentially all I've done is 2 maneuvers to eliminate x into equations, right? Which we did before. It was a little bit messy. I mean, it's a little bit more organized here, but if I keep going here, I've got 6, 34, and what is that, 25? And that's my new row 3. 0, 6, 34, 25. Excuse me. So, excuse me. The next thing that I want to do, right? I'm almost there. Again, the goal was to make this look like this. So this is the goal. And I just got that, right? So the next thing I want to do is I'm going to completely leave this line alone. The next thing I want to do is get this guy right here to be a 1. And I can do that by simply multiplying through this entire row right here, 1/3. Or if you like, think of it as dividing by 3, right? So let me clear up a little bit of junk here. You and you. I'm going to take and say that my old row 2 multiplied by 1/3 is going to become my new row 2, right? And that's the only change I'm going to do right now. Okay. So I'm going to leave row 1 alone, 1, -2, -10, -6. This all gets divided by 3 essentially, so 0, 1, 8, and 3. Okay. And I'm not touching the last guy, so 0, 6, 34, and 25 still. Okay. Right. So again, that goal did that, did that, did that. I've now done this, and I'm going to use this 1 to get that 0 right there, right? So that is to say, I'm going to take -6 multiplied by my old row 2 and add it to my old row 3 to become my new row 3, specifically targeting that 6 to get rid of it, right? Doing this math off to the side, right? If you have to do the math off to the side, do it, right? It's easier to do it and see if you've messed up somewhere. But -6 row 2's is -6 times 0 is 0. -6 times 1 is -6. -6 times 8 is -48. And then -6 times 3 is -18. So that's -6 row 2's, and I'm just going to plop a row 3 under it. 0, 6, 34, 25. Adding those 2 rows, I get 0, 0, which is what I wanted. Excuse me, -14, and then 7. Okay. So that's my new row 3. I'm going to rewrite my matrix. And there's a lot of rewriting stuff here. But I didn't touch row 2. I don't want to change row 2, that is. But I did create a new row 3, and that's my 0, 0, -14, 7. Right? So now I've got my 0 here. The last thing that I want is a 1 right there. And the best and easiest way to get a 1 there without messing up stuff that you've done is just to divide by that number that's there, or multiply by. So I'm going to multiply by -1 over 14. Or you can think of it as just dividing all those entries by 14, right? So if I do, I'm just going to rewrite my matrix one last time here. This is 1, -2, -10, -6, 0, 1, 8, and 3. And then this last one I'm dividing by -14, so I get 0, 0. That's a +1 and -1/2, right? And so the Gaussian elimination is now complete. The translation of this is, again, this is an X column, a Y column, and a Z column. So this is like having X minus 2Y minus 10Z equals -6. And then Y plus 8Z equals 3. And then Z equals -1/2. So we've solved for one of our variables. I can take that and back sub into the next one, solve for Y, and then take Y and Z, back sub into the first one, and solve for X. And that process is the Gaussian elimination, right? So if I do plug in Z equals -1/2, this then becomes Y plus 8 times -1/2 equals 3, or Y minus 4 equals 3. And so if I add 4 to both sides, I get Y equals 7. Now I'm going to take Z and Y into the last one and solve for X. So that is X minus 2y, which is 7, minus 10z, which is negative 1/2, equals negative 6. Or x minus 14 plus 5 equals negative 6. Or x minus minus 9 equals, there we go, negative 6. And then add 9. And we get x equals 3, and I've solved it. X is 3, y was 7, z was negative 1/2. And that's it. That is my solution, right? So that's the Gauss elimination. A guy named Jordan came by and said, well, why would you stop there with the matrices? And Gauss was dead, so he couldn't answer. But Jordan came and said, let's just keep going with that, right? And the Jordan elimination method is to, I don't see a good picture of it, but the Jordan method is to do the Gaussian elimination, but then just continue all the way. So the Gauss-Jordan just says, hey, Gauss, you're dumb. Why did you stop? You can keep going. And Gauss says, if you can get 1, 0, 0, 0, 1, 0, 0, 0, 1, augmented with whatever, A, B, C, right? Then you're done. X is whatever A is, Y is whatever B is, and Z is whatever C is, right? So if you can keep going, then you don't have to go and do this back substitution method, right? So let's take a look at doing one of these, and this is my preferred method. I don't know a mathematician who likes to do the Gaussian method, but not just go all the way and do the Jordan method. So let's try this guy here. And it's going to be very similar. It'll be a similar method, but we're going to do just a little bit more, and it's ever so much smaller, more work to make it so much easier, I think. But again, first and foremost, I'm going to write this as a matrix. And so if my pen will catch up here, I have 3, -4, -1, and 6 in my first row. 2, -1, 1, and -1. 4, -7, -3, and 13. Okay. So now again, I can't see why. I'm going to steal this. This is the picture of the last problem. So this is not the answer to ours, right? So we're going to have things like different numbers. I don't know what that's going to be. It's not going to be a 3. That was the answer to the last problem. But I want my left hand, looking at the left hand of this matrix, this is what I want to get. And so the very first thing that I want is that 1 right there, because I can use that 1 to eliminate the rest of that row, column. And then I'm going to move to the next one and use it to zero out the rest of its column. And then I'm going to get the next one and use it to zero out the rest of its column. That's the general idea here. Okay. So on the last one, we were lucky enough just to swap a row and get a 1. I can't do that here, but I can easily take row 1 and subtract row 2 to become my new row 1. And I'm not going to change row 2, and I'm not going to change row 3, so I'm just going to indicate with just an arrow that they don't change. And my new matrix, row 1 minus row 2, is each element in row 1 minus each element in row 2. So that is 3 minus 2 gives me the 1. That's why I did this. -4 minus -1 is the same as -4 plus 1. That's -3. And then -1 minus 1 is going to be -2. And then 6 minus -1 is 7. Right? And that's the only change I've done, so I'm just going to rewrite the other two rows. They have not changed. So 2, -1, 1, -1, 4, -7, -3, and 13. Okay. Now that I've got that 1 right here, I'm going to do something very similar as I did in the last problem and just eliminate the 2 and the 4, right? And then whatever happens in the rest of it, I just have to deal with, right? But I can use that 1 here by saying if I take -2 and multiply it by row 1 and then add that into my old row 2 to become my new row 2, again, the whole point of that is then to eliminate the 2 in that spot to become 0. And so I'll do the same thing here. It would take -4 row 1s to do that here, added to row 3 to become my new row 3. Row 1 in this step is not going to change. So row 1 is not changing. But row 2, I'm taking -2 row 1s and adding it. So in my head, I typically do this in my head, but if I'll write it down here, -2 row 1 bit by bit is -2. -2 times -3 is +6. -2 times -2 is +4. And then -2 times 7 is -14. And then I'm adding that to row 2, which is that. So I get 0, which is what I wanted. 6 minus 1, 5. 4 plus 1, also 5. And -14 minus 1, -15. Right? Likewise, for my other guy, -4 row 1s would be -4, +12, +8, and -28. And then adding that to row 3, 4, -7, -3, and 13 gives me 0, what I was looking for. 5. I hate this book. You'll see why in a minute. 5 and -15. Hate this book so much. We're not even ready for this, but here it is. So what happens now? I'm done. I don't even have to continue the problem, which I really wanted to go through a problem and not just get stopped on something stupid. But here we are. And it's not stupid. You definitely need to know it. I have the same equation here, right? And so what happens when two of my equations end up being the exact same, right? If I tried to eliminate, I would end up with 0 equals 0 essentially, which is my true statement, right? Which then tells me that there are infinitely many solutions. And I hate that they put that as the second example on every goddamn section. Let's find one we can actually work through so you can see the process. Ooh, they have no more examples. Cool. Let me make one for you. Because this is ridiculous. Okay. And then let me make sure that it is consistent. It is great. All right. I hate this book. I hate it so much. But here's an example I've made for you so that we can actually go through the process. Let's just do this. Clear. Let's start from scratch. If I have the system 3x minus 2y plus z equals 2, 2x minus y plus z equals, really, is it 2, 3, 4? And then 3x minus 7y plus 5z equals 4. Okay. So the first thing that I would do is rewrite this as a matrix. So I have 3, minus 2, 1, and 2. Right? And then 2, negative 1, 1, 3. And then 3, negative 7, 5, and 4. Right? All right, so the first thing that I want is to get a 1 in, okay, that's an eraser, in this position, right? I can't swap rows because there's no 1 hanging out there, but I can simply take row 1 and minus row 2. So I'll take row 1 minus row 2 because 3 minus 2 gives me 1. And that's my new row 1. So I'll write that. Row 1 minus row 2 is 3 minus 2 is 1. Negative 2 minus negative 1 is negative 1. 1 minus 1 is 0. And my augmented 2 minus 3 is negative 1. Now I didn't change any of the other rows, so I'll just rewrite them. Okay. So I've got my 1, and I'm going to use it to get rid of the 2 and the 3 underneath. Right? So, and I'll do that again by using negative of whatever number is here. So negative 2 times row 1 and add that back to row 2. That's my new row 2. And I'll do the same thing, the negative 3, row 1 added to row 3 is my new row 3. And row 1 is not going to change. So that is 1, negative 1, 0, negative 1. And if I'm taking negative 2 row 1s plus row 2, I can just go bit by bit, right? Negative 2 times 1 is negative 2, plus the 2 from row 2 is 0. Negative 2 times negative 1 is a positive 2, plus negative 1 is 1. So we're kind of lucky. That was going to be our next step. Negative 2 times 0 is 0, and then I add 1 is 1. And then negative 2 times negative 1 is a positive 2, added to 3 gives me 5. And we'll do the same thing over here. So negative 3 times 1 is negative 3, plus 0 is 0. Negative 3 times negative 1 is a positive 3, plus negative 7 gives me negative 4. Negative 3 times 0 is still 0. Add that to 5 gives me 5. And negative 3 times negative 1 is a positive 3. Add that to 4, and I have 7. Right. The next step would be to get a 1 in this spot so that I can use it to eliminate the rest of that column. I've already got the 1 there, so I'm just going to move straight into eliminating the rest of this column. And I can do that simply by taking row 2 and adding it to row 1, right? Because that's not going to mess up the 1 that I got here. It will eliminate the negative 1 that's there. So that's my new row 1. And I'm going to take 4 row 2s and add that to row 3. And that becomes my new row 3 so that I can eliminate the negative 4. So writing this, Row 2 is not being changed. And so I end up with 0, 1, 1, and 5 for my middle row. I'm just taking row 2 and adding it to row 1, so that's easy. 1 plus 0 is 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. And 5 and negative 1 is 4. On this other guy, I'm taking 4 row 2s and then adding it to row 3. So 4 times 0 is 0. Add that to 0 is still 0. 4 times 1 is 4, plus negative 4 gives me the 0. 4 times 1 is 4. Add that to 5 is 9. And then 4 times 5 is 20. Add that to 7, and that's 27. Right? Right. So you can see that this is starting to build. Right. I've got 1, 0, 0, 0, 1, 0. The next thing I need is a 1 right there so that I can zero out the rest of that column. This is easy. The only thing that I can do here is multiply this by 1/9, or divide by 9 if you like, right? I can't add multiples of the other rows, otherwise I'm going to mess up with these zeros, and I don't want to do that. So I'm just going to multiply this by 1/9, and that gives me row 1 and 2 are unchanged. 1, 0, 1, 4, 0, 1, 1, 5, and then this is 0, 0, 9 times 1/9 is 1, 27 times 1/9 is 3. And now I'm going to eliminate those ones. And I'll do that by taking, and it really is easy here. I just have to take, say, row 1 and minus row 3, and then row 2 and minus row 3. This becomes my new row 1, this becomes my new row 2, and I'm not changing row 3. So in the end, row 1 minus row 3 is 1 minus 0 is still 1. 0 minus 0 is still 0. And 1 minus 0 is 0. 4 minus 3 is 1. And we can see x equals 1. Same thing here, row 2 minus row 3, 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, and 5 minus 3 is 2. And I'm leaving row 3 alone, so 0, 0, 1, 3, and I have it. X equals 1, y equals 2, z equals 3. All right. That's it for this section. It was a couple of examples, but hopefully that'll get you started. If you need more help, feel free to ask me to do more. I can take a video of me doing more of these. There are also videos on YouTube, Khan Academy, other places where you can see examples worked out. But other people may not do them the same as I do, so that could be a good thing or a bad thing, depending on, you know, how you learn. If you want to see other people doing them, it's a great idea to go look and see how they do them. But if you want me to do more examples, let me know. I can record a couple more of these problems. But yeah, that's it for today. So thanks and see ya.